From a talk where types were irrelevant to a talk where types are doubly relevant, Ollie is here to tell us about adding pattern types to the type system. Ollie has been a compiler team member for 7 years, worked on Rust full time for 4 years, and tomorrow marks 10 years since Ollie's first const eval contribution to Rust. So that's very exciting. A few things happening tomorrow, as it turns out. So please make Ollie welcome.
So, um, this talk is going to be initially just a quick intro into pattern types, but then I'm digging into how it's actually implemented in a type system. I think it should be generally understandable, but just ask questions afterwards. Lots of questions. So quick intro. What the heck are pattern types? Well, they're basically types that are not the full value range of their original type. So if you have like an integer like u32, you can limit it to like 1 to 100 or something, and can dump a value in there, and it will just work because 12 is obviously between 1 and 100. But if you try something else, you get a weird compiler error because this feature is not meant for public consumption. This is literally there to make the compiler easier. Yeah, use it, but only use it in a compiler, please. um, and there's also one interesting part that is pointers. Pointers can be not null. Anybody ever seen a bang null pattern? No, because it doesn't exist in patterns. I just hacked this in so we could replace the non null type in the standard library. Yeah, if before we ever get this to anybody outside of the compiler, we'll have to have a long discussion with the Lang team about that one. So the correct way to initialize one, you just saw I did it with a bunch of numbers, but what if the number is out of scope or you want to have a runtime value? The compiler can't check runtime values, so transmute. It always gets you all the right values unless you do UB. So that's bad. So what's the better way? The better way is you match on the value. If the value matches the pattern that you gave, you do all the unsafe code here, converting this to a pattern type, and otherwise you get a none. This is a nice macro that I just added for myself to the standard library so stuff would be easier. And the previous implementation that we had like all this complicated code for ensuring that like a range pattern is like the value is like below the range, above the ranges aren't like overlapping, going the wrong direction and stuff. And now it's just like match on a pattern. It's so much cooler. So the actual best way would be if we had like language support for doing stuff, but like not part of this talk because this talk is not about actually doing cool language stuff. Sorry, this part is about compilers. Um, so compilers. What do we actually want from pattern types? If we declare a pattern type like this one, we know it only has valid values from 0 to 100. So this U32 is like has a lot of bits that are unused. And we can use those bits. The compiler is using those bits. If you've ever used a non-zero, non-null value and you stuck it into an option, it was the same size as the option. Same thing works here. You have the size of percent. I don't know what the size actually is, probably 4. And this size of the option of percent is the same size. And this stacks. This is the same size as the original percent. And this size optimization is really useful, especially if you're doing like interop with other languages, which have like non-null values like randomly everywhere. So if you want to use like nice options and stuff, that's really helpful. So why did I start all this work? Well, why did I start implementing pattern types? It's not just for a cool feature or something. It is for replacing whatever that long attribute is. I keep forgetting how to write it. Like I literally had to go look it up to write it in this thing, even though I've been using it everywhere. This attribute is a compiler internal hack to change the layout of this struct, even though internally it has a U32, to tell the layout of this struct to be like, well, except for the value of 0. Oh, except for the values below 1, but that's for unsigned integers, that's 0. And this attribute, it was a pain. Because if you now access this integer and just write a list 0 to it, that's UB. If you take a mutable reference to this integer and send it to someone else and they write a 0 to it, that's UB. And there's like a billion other ways to make this UB. And we made this sound, which was a lot of code, just for an internal compiler feature. So my hope is pattern types will take less code, and currently it's looking at least at it's more maintainable, not necessarily less code. So I want to replace that one the non-zero U32 in libcore with just like a struct that wraps a U32 as one dot dot. And now you're actually allowed to reference this field in there, and everything is fine because this type, you can't do anything with it. Like a pattern type right now in standard library that you use, it's like it has no fields, it has no methods on it, it has nothing. So all you can do is transmute it back to U32 because sometimes you need to get a U32 out of a non-zero U32. But that's already the case for non-zero U32. It's like when you're using it, you only have a bunch of methods on it. You never access its fields. The field is private anyway. So for all users, this doesn't actually do anything interesting. So done with intro. Now we're going into compilers. So I try to add pattern types as like the syntax where you say like U32 is one dot dot to the language, and immediately somebody's code broke because somebody wrote a macro that internally writes like tie and then followed by an is, and then my parser was like, but that's already a tie, and then everything broke. So we had to stop doing that. We'll probably do it over an addition, or we find a new syntax, but we're not trying to do that. So what I added was a macro to standard library that has a lot of compiler magic here. But it's basically just these two things where tie is null or tie is pat, and then the compiler figures things out. And by figuring things out, I mean the parser is literally like, check if there is a bang after the is, and then require that as a null, or just parse a pattern. And so we either have a pattern, like you saw here, pattern, or we have a null. And then we stuff all that back into an AST representation. So you already know patterns that you use in macros all the time. They have like all these different variants, but pattern types, they don't really know that much. They have not null, they have ranges we've seen, and if or. We'll get to or later. But like we are really trying to limit what you can do with pattern types for now, and we're treating them as a completely separate concept, and we might merge them back together again at some point or make stuff generic. But for now, we keep it in a completely separate code path that we can just analyze and exhaustively match, and everybody's happy on that count. So when we parsing, I said we parse a pattern. So we get a pattern. That's a normal pattern that you see everywhere, and we want to turn that into a type pattern because, well, we want to have the simpler representation. So basically, we're just moving values from those dot dots to those dot dots, and the or does the same thing. And we don't even have not null because they don't exist in the normal one. As I showed earlier, we just handle them as a separate code path, and everything else just puts out like a really not helpful error. At least the span is nice. I took some effort in making the span nice. Yeah, it's not on the level of diagnostic that we would ever want, but it's usable for inside the compiler and inside the standard library, so that's good. Now, that's the AST. I have to move this into the type system. So how does this actually look right now? When I started, I had a range pattern, and the range pattern has a start. But it not necessarily has a start. It only sometimes has a start because you can just write dot dot 5, which has no start. So there's a none for the start. And then there's a constant because you could be writing one dot dot. So for that, there would be constant here. You could also write like named constant and so on, but like that's fine. The end has the same thing, and then we have an include end because you could write dot dot equals or dot dot. And this representation just represents exactly how we would represent it in the AST because that's how ASTs works. They just represent what you're writing. In the type system, this has a bunch of problems. So when you have a U8 is 1.100, you have a sum1 for the start, you have a sum100 for the end, and you have like this, is the end inclusive, which is no, because there's no equals here. But look at this one. This one, these are like the same. And like, but they look different because this one has a sum99 and has a true here. So we have the same type technically, but differently represented, which is fine in the AST because the AST just should represent what you're writing. But in the type system, these two types are the same and they're not the same. That's bad. And so initially I was looking at like, how can I make this better? Can I like figure out how to make the type equality checks, like figure out, oh, if there is a true here, then I need to add one to this and compare to that. And then, well, let's simplify. First simplification, let's get rid of the options because those are already a little bit annoying. So the AST doesn't change. What we're changing is the representation in HIR and in the type system. And so whenever you see a missing start or end, you look at the type and just insert the right, well, start or end. But at the place that we're doing this, we don't have type information yet. So we need to figure out how to ask the compiler to later fill in the correct value here. And earlier I already showed you that we have constants here. And constants, they can't just be integers. They can also be projections into traits. So what it was in the standard library, I declared a trait that basically had max and min values for all kinds of integer types and for characters. And so in the lowering from AST to HIR, I see, oh, there's an option. Well, just rip out the option, take the type, because we're saying like the U32 is some pattern. The U32 we have available, so we just generate this whole U32 is my super weird fancy trait, max, or min, depending on which range we want. And that allows us to change these to at least have no options anymore. So you see it doesn't run out of my screen anymore. That's good. But we still have the dumb thing of like this Boolean here that makes us distinguish between equal types but unequal types. So the next step is, how can we get rid of this difference? How can we just get rid of this Boolean once and for all and have this kind of representation? I mean, this is super easy to represent and to understand and to equate, because we can just equate the start and the end, and if there's a difference, then they're different. There's no more logic that you have to put there, but you have to figure out how to get the end properly stuck in there. And well, we have subtraction, I guess. So if we represent this one, which doesn't include the end, as 100 minus 1, that works actually pretty nice. It works for integers at least. And then we can represent all these values as just basically a tuple of 2 integers. And the type system is fairly happy with this one. Well, right? Well, the problem is you still have ranges that people can specify, like, let's say 10 to 5. So runs out of the back and comes in from the start or something. But yeah, that might be doable if like people actually write numbers, but what if people write generics? How do you do this here? Like I could write something in compiler that literally checks like the constant value, but like in this case, there's no constant value. This is something that will get filled in later in the type system. Like somebody will insert an A and a B, and they could be inserting them in the wrong order, or somebody could have flipped the order of the generic parameters here. So we need to figure out how to actually compare the range ends here. And the good thing is we don't need it for our standard library stuff. So now I'm extending beyond what we would need to actually change the standard library to get rid of those weird super long Rust-C attributes. But now we're getting more into stuff that we can do in the future and be working on. And so remember I told you about this trait that's like this min and max, and it also has a weird function for sub1 because I needed to subtract 1, and it was very hard to write out like how to subtract 1 in the compiler. So I just made a function call because that's easier. But with characters, it's even worse. So if I want to subtract from characters, how do you subtract 1 from characters? Like I can't do minus 1. So I converted back, where are we? There. The sub1 function itself, it converts the integer, the character to U32, subtracts 1, tries to convert it back to character. In case it doesn't work, gives you a panic. And in case it works, it gives you the value. And diagnostics in that are surprisingly good. Like, this works pretty well. But the problem is, if you start using this in generic contexts, you still have to somehow call the sub1 function. And if you've ever used like the const generic expression stuff, it does not like it if you like do things that panic. So yeah, we'll need to do something better here. So initially I was thinking, let's just scrap char and like let's like look at integers. But then I looked at integers and they were like, oh, that's just the same code. So it has the same problem, obviously. So we're thinking a little bit more about how to do this properly. And so here's a bunch of examples that I will go through one by one, and then we can think about what the problems with them are. The first one, we have generic A and B, and we just compare them, and it's B is inclusive. That's easy. We just convert them to A and B. We put those into those constants. We say constant start is A, constant B end is B. Everybody's happy. Now, if we stop using equals here and say like B is not included, that means we need to subtract 1 from B to do our nice representation thing. And that means we now have this inside a constant. So there's a method call here that could technically do anything and could technically panic, and it will actually panic. So we need to take care that this doesn't panic. And well, I leave that to the next person holding a talk here, so we won't talk about that one today. But here you can see if we're just going to one value and leaving out the first one, this one's pretty easy. There's a constant here. It's we're just projecting into that one. That's completely fine to do. So what is actually the problem with the one up here? I need to skip over a slide, sorry. The problem is we need to make sure that all our types are correctly represented in a type system. So we need to, at any time, be able to check, is this type actually valid at the current position? And usually you do that by looking at your where-bounds, or you're looking, if you don't have any where-bounds because you're completely monomorphic, you just don't have to do anything interesting. But we want to do all of this in generic code. So when we have a function like this, function foo, ignore that one up there, we need to check that this U32 is actually smaller than 10. And there is like 3 different ways to do it, and they're all equally like icky. So we're looking into how to do that one best. Right now, the compiler actually correctly handles this. If you have all these features turned on, and some of them are like incomplete, so you get warnings about incomplete features, this will actually error with an error that doesn't actually show you where the error is from. This is all the error that the compiler spits out. And we literally cannot do better than this. At this stage, that's part of the problem of the whole generic stuff. At the point where we know that something is wrong, we don't have any information left to actually tell you where it went wrong. So the only way to do this is to know at the signature of the function foo where something went wrong. So when we're declaring this function foo, we would somehow have to extract this pattern types information or add some where bounds here that declare that this A must be smaller than 10. And that's the entire problem that we need to solve to make pattern types actually work. So to get further with pattern types, we first have to do a bunch of lower level type system stuff around const generics to get somewhere interesting. Right. So what solutions do we actually have? We can generate some implied bounds or something where we see like, oh, there's a pattern type in the signature. So the compiler could generate magic stuff that you can't write yourself. But that breaks down when you're only using a pattern type in the body of a function, because now you can't say that bound anymore. You could add like dummy where bounds and so on, but it gets really annoying. So maybe there are other solutions. We could have like an untyped integer type that's like a big num in the type system that you can't actually put into the normal into normal runtime code. But that it has its own problems because untyped is not really something that Rust does. So we'll have to find some better solution than that. And then we could special case just pattern types to be able to work around these limitations we put there on purpose out of good reason. Because if you're looking at like arrays, like you can sometimes declare arrays that fail in the same bad way as this one, where you just get like a one-line error that says this array is unfortunately too large for your platform, and it changes between platforms. So yeah, we want to avoid that and make it better. And so yeah, we're looking into all of those solutions, and we're trying to figure out one way to make it better, and might take multiple ways. But for now, standard library is getting easier, compiler is getting easier, but the feature itself needs a lot of work and a lot of thinking. It's not actually needs a lot of implementation work. It just needs really a lot of like thinking work how to do this correctly. Yeah. That was me on pattern types in the compiler.
I appreciate that you've left us on a cliffhanger for the next talk. Okay, questions. I feel like there'll probably be a few. Okay, I am gonna come that way to start with.
I should have brought sunglasses.
Hi Ollie. How bad would it be just not to support open ranges?
Not that bad. It's just you could just say we always need inclusive ranges.
Yeah, sure.
And since we're also thinking about just never allowing floats for pattern types because those are also annoying. So if we're already limiting, we could limit it more. That would simplify a few things.
Would
Correct.
that be useful enough?
It would avoid the subtract one issue, but it wouldn't avoid the flipping, where you have an A that's larger than a B. And in that case, like we need to do it anyway. So
Fair enough.
there's no like on top of that check, it's not that much more.
I see. Thank you.
Could you
Just say
say
down here.
that empty ranges are just empty instead of being not well formed?
Empty ranges are just empty instead of not being well formed. Oh, yes, we could do that, but that's different from what pattern matching does. So we don't want to invent too many disconnected concepts. We want to try to make pattern matching and pattern types at least like not have disjunctive features. They are allowed to not have all the features of each other, but like at least not like, well, pattern types are supposed to be a subset of patterns, basically.
And I guess riffing off of that, is the range 1.1 just not well formed, or is it the never type?
1.1 is an error. You can't write that as a pattern either, so we're actually erroring out on that. You can write a pattern that is only a single value, though.
There was somebody up here, a couple of people up here. All right.
I was wondering with the when the use case is already just super limited, you have to transmute. Why the effort of making like those patterns that are logically the same, actually the same in the type system? Why not just keep them separate and then save the sub one stuff? And
So the main reason for that is that in the type system, I want it to be simple anyway. Like it is not to support all of these use cases. I could have just removed it from the syntax, so that the AST is not allowed to represent it either and error it out at that stage. That would have worked. But in the type system, I want to have the simple type system that I can actually reason about and explain to people like what's going on instead of just hoping that I did everything right.
I was wondering, could you for now limit the pattern like start and end to just be literals instead of like supporting all those constants? Because to me it seems like for what the standard library needs and for what a lot of people would use this feature for, just having literals instead of any arbitrary constants would be more than enough.
So differentiating between literals and constants at the type level, there's no difference anyway. So I would only have to make the difference at the AST or the HRR level, and at that point, I don't think we gain that much. Being able to specify like constants somewhere that declare the limits of your type and not having to repeat the things or use too many macros is what I try to allow. The previous system with the attribute, it was very, very limited. It only allowed literals, but yeah, it didn't cost anything extra to just allow constants.
I think as a remark, I think for the character type, you should skip the surrogate pair range instead of -1 because you can have dot dot the surrogate pair. The end of surrogate pair range, you should actually skip over the whole surrogate pair range instead of just -1 because that will panic.
Right. If you're right, that would actually be the more correct implementation for char. You're right.
All right, I know there are a couple of people down the front. Give me 1 sec to come back down without breaking an ankle. Okay. Okay. All right.
So somebody commented about floats earlier, and I know that there are a lot of people who want to apply this to float types for things like non-nan, non-infinity, non-zero. They don't necessarily need full ranges, albeit they might want non-negative, for example. But I'm wondering if that makes it any simpler. And in the broader case, like you talked a lot about integers. Could you talk a little bit about like the enum case, the more general pattern case of, I have a this that is only this variant, that kind of thing?
So with floats, the answer is very simple. We don't have that in patterns. If we're not able to match on it, then we're basically not. And we're basically not adding it there. But at that point, yeah, it would totally be possible. And with all the problems that we have with floats and const generics in general. You saw the OR pattern that allows you to specify separate ranges, and one of the ranges has to match. And you could use that to match on enums in the future, where you create an enum that is only a subset of the actual enum variant. A result that's only error, or the case we have inside the compiler itself is we want to exclude some types, some type variants in specific locations because we know they can't happen anymore. Yeah, there's definitely a lot more space for adding more features to pattern types, but that's less implementation work and more talking about what we actually want from it.
Just quick question about the ABI representation. Does this work? Does it affect at all the internal?
It affects the layout, but it does not affect the ABI itself, in the sense that you can always transmute a base type of a pattern type, like a U32 to a U32 that is any other range. You can always do that in both directions, and it's the same in function signatures, so you can just change it in function signatures as long as you're guaranteeing that everybody's sending the correct values, obviously. But yeah, it has the same ABI that's not actually being touched.
Okay, do we have anyone else?
Hello, yeah. Would it make sense that instead of like specifying the type directly, you would define like a magic trait that contains like this magic associated type that is implemented only if the actual pattern is valid, has a valid range? So you hide the actual pattern type behind something like a magic associated type.
Well, right. So you're declaring basically a trait that has the range ends as generic parameters and has an associated type that gives you the pattern type.
Yeah.
I'm not sure that would actually solve that much. We could specify all of that in the signatures and so on. So we could basically bubble up the subtractions and all the way up. But
yeah, because with this, then you can specify this in the where bound. So if it's a const generic AB, so now you require that this range AB to implement this pattern trait.
Right. That would absolutely work. I'm just pretty sure it's not the kind of signature that people would want to write. I mean, it's similar to like you can basically do this with type num. Which works. It solves a lot of these problems because it's just completely in the type system, but it's also like very verbose to write.
Okay, thanks.
All right, I've been told we have time for one more. Yep.
Are there plans for, or do you have a status on taking this data and putting it in MER, or is that already done?
So this is part of the type system that flows into everything the compiler does. So MIR and MIRI and everything, they see these values.
Okay.
MIRI is checking how non-zero and non-null types work, and this doesn't change any of that.
Yeah, cool.
Well,
Thanks.
famous words, because the PR that's implementing that is breaking MIRI. I'm fixing that.
All right. Sounds like there are many questions and a lot of discussion on this, but that's all we have time for now. Please say thanks again to Ollie.